Okay. Well, welcome to day 4 of Quick Pass. I hope that everybody had a nice holiday and was able to work on the exercises and get some questions answered. I know I answered some questions over Slack over the holiday. Not on Christmas, though. I do not open Slack on Christmas. Um, but again, this forum is always open. The Slack, we're pretty responsive with it, and we will try our best to answer questions in a timely manner, just so you guys can have enough time, enough help and enough time to finish the exercises. They are for your benefit. Um, and I just urge, if you're feeling discouraged because it's pretty hard, just stick with it. When we get through everything, I think you'll have a lot of stuff in your toolbox that you can use to solve the problems in the application process. And then, of course, the live coding exercise. We're going to do a bit of a deep dive for the next few sessions. We're going to go over the data types and go over a lot of the methods with them. And we're going to open with strings. So this lesson is entirely all strings and all the methods involved with them. And hopefully at the end, you'll see how we can use these methods with strings to really break down data at the lowest level and work with it. And I'll show you some pretty good stuff. So let's go ahead and get started. So if you notice that we're in week 2 now, this is going to be structured based on if we didn't have any holidays, but we have a lot of holidays through the Quick Pass window. So we are in week 2. So it'll be the first lesson in week 2, and it's going to be over strings. This should be a relatively short lesson, which is nice because it gives me quite a bit of time to go over examples, and show you some other string tips, how to manipulate the string types, and then we'll have time to go over the exercises for both this session and also the previous sessions if you have any trouble with those. So I am going to open with the lesson though, so we won't do a review over the exercises from last week, but we will at the end. We'll go over those in class after I get through the formal lecture. And then, I'm sure some of you have some questions on some of the exercises. But this is going to be a lot more in-depth, and it's going to be over one data type, so you don't have to think about all the different data types. I know I kind of threw them at you in those first lessons. So with that, this is the Python strings and their built-in methods. I would like for us to kind of think about, strings in general, what we do remember from last week. What are some attributes of strings that you remember?
Length.
I'm sorry, what?
Length. Length.
I don't know if you're coming in clearly or not. Oh, length. Okay, so they have a length. Yep, you can have double quotes. They're a list of characters. Yeah, so some of those things, is there anything else that stuck out to you about strings? There's one more attribute that I kind of want to just everybody keep in mind. Yep, there it is. So Jordan said it, immutable. So strings are immutable, so you cannot change them in place. If you want to change a string, you have to redefine the entire variable. You have to redefine the string. So you can change it, but you can't change it in place like you can with a list. So strings are like lists as far as they behave like them a bit, but they aren't mutable. So you can't change them in place. So I did want to kind of show a quick graphic to everybody, and I'll share this in Slack as well. Let me see if I can make it a tad bit bigger. There we go. So this is an example of a we can use this for both strings and lists, but we have, in this case, we do have a string, and it's broken into boxes. So you would have the quotes around it. You can access each character in a string using its index. And so I remember last week I did sometimes show you how I can access the index by using these square brackets. And at the 0 index, because we always start when we count up, we always start with 0 and we count up towards the end of the string. On the other side, you can access starting from the end of the string going backwards by using negative indexing. But negative indexing starts at -1 and then goes backwards. So index 0, in this case with hello, with the exclamation point, index 0 is the same exact thing as index -6. They would get you to the same exact character. So I'll share this in the Slack channel so everyone has this as a reference. It's a pretty good reference. Kind of gets you thinking about how we do indexing. And in addition, we also can do string slicing, which gives us a portion of a string. So we can get like a range of the characters. So I can just grab like the ELL, for example, and return that back by using string slicing. So we'll go over that as well. So again, I'll share this into Slack a bit later, so everyone has that reference. Any questions on that? Okay. So we're going to go over quite a few built-in string methods. And so if you remember when we talked about methods or even functions, if you will, methods are some coded behind-the-scenes stuff that we can do in the Python code that allows us to manipulate these data structures. I know I've touched on a few of these already, like in the case of upper, for example, will then return the string with all uppercase characters. And we'll go over all of these to help, this is kind of like tools in a toolbox to help us manipulate the string data structure. And then we're going to go over F strings or interpolated strings. I'll also show kind of the older Python way of doing things. That way you guys, if you run into that in your code, you'll know what to do with it. We'll talk about escape sequences, and then the string slicing and reversing. So I was talking about that when I was showing that illustration with the indexes. You can use those indexes to slice, and then we'll go to conclusion. And we have a few exercises at the bottom. If you've opened up the GitHub repo anytime early afternoon, you probably won't see it. So you may want to refresh. You'll be able to see the exercises we put at the bottom, and they're pretty good with strings. Any questions before we get started? Oh, is there a good site or cheat sheet for definitions of Python terms or definitions? I think I shared one of them. I'll have to take a look back exactly what I shared. But yeah, let me find a good resource there to show you the terms. I think we do have. I have something, I know. Yeah, I think it's the wiki, but I mean that's again the terms I'm sharing here, like method and function and variable, those things, slicing, those are a lot of the definitions that I can yeah, I mean there's a link again. Looks like Errol went ahead and shared the link to that. Great. So let's go ahead and dive right in then. So we're going to dive right into these string methods. Since I already did talk about kind of what we're going to go over slicing. Before I do that, I did want to kind of show you again. I have a string here. Go ahead and say my string equals my string. So leave it like that. Again, if I want to access the index, I can either do the print function on here. So I can do print my string. If I want to access the first index of it, I would do open bracket 0. Put the G back in there. There we go. And if I run this, I'm going to get back the first letter, which is an M. So using that indexing, I'll go over the slicing once we get to that section. But just remember that we can access each individual index using that syntax. So starting with string upper, this one converts all the characters in a string to uppercase. And it's useful for ensuring that we have consistent formatting or case-insensitive comparisons. If you ever noticed when you go to like a login page and I notice that whenever I copy and paste my email, or if I'm trying to enter my email in, like a lot of times my text gets auto formatted with a capital A for my first name in my email address. And I just leave it and I submit it because there is somewhere in the back end, somewhere in that code, when my email is being sent over, I'm trying to log in, it will actually convert my code, my email to all lowercase or all uppercase strings. So when it does a comparison with what's in the database. So that's all happening behind the scenes. And this is the method that does it. Conversely, you have string.lower, and that will, of course, convert everything to lowercase. It will ignore any like letter. So if you have a 2 in there or something else inside of your string, of course, there's no lowercase version of a 2. It will just ignore it. It won't give you an error. So anything that's like an alpha character will be converted to the lowercase or uppercase, depending on which one you use. So in this case, I have like text 1 here, right? So here I can say, okay, well, text 1 dot upper. And if I run that, I get all capitals. Or I can print it with the Jupyter Notebook. It will allow you to just kind of call it with its method without actually saying print, and it will give you an output in the console. If you take a look at the difference between just doing that and doing print, if I run that, I don't have the quotes around it. So sometimes it's easier just to kind of see what it is with this one. Again, Jupyter Notebooks are not really teaching it, but if you are really interested in using a Jupyter Notebook to kind of to practice some of the stuff, when we get done with the lesson and everything else, or even offline on Slack, I can give you some pointers to using these, or you can continue to use Replit, or if you have ventured into VS Code land, you can use that as well. I'm using Jupyter Notebook inside of VS Code. So, but here we saw that the upper returned a string with it all uppercase. Let me go ahead and add a new one. Okay. And let's do the next one. Text 2 dot lower. If I run that, of course, I get them all lowercase now. So quiet down becomes all lowercase. Any questions on those? Those are pretty easy. They're pretty straightforward. There's no mystery with those, but they are useful for like data validation, those types of things. When you get into authentication, stuff like that, it will help you validate some data. And if you get into Code Platoon and you're doing some of the exercises, they will have data validation exercises where you'll have to use that. So it's a pretty cool feature. Okay, for the next one here, we have string, we have dot capitalize. And this one here will capitalize the first character of a string and make all others lowercase. So, just note that if you have a capital letter later on in the string, it will lowercase anything else. So it kind of does two, makes the first one capitalized, the rest are all lowercase. So there's really nice examples with this book. So I'm just kind of showing different examples, but it all works the same. In this case, we have text 3. I can just do that and then run it. And now Again, everything is lowercase, but they did capitalize the W to make it a capitalized sentence in this case. For this next one, we have the title method. This one capitalizes the first character of each word in a string. So it will actually evaluate for spaces. And then, if there's like a substring, it will kind of find substrings and then capitalize the first letter of each one. So it's useful for creating title case text. So I believe you had one of the exercises from last week called like camel case. I believe. Um, Conversely, you could use the title case, to kind of go backwards from that. So go from camel case to title case. You could like get rid of the underscores and then, replace them with spaces and then capitalize each word in that statement. And then you can like mash it together and get rid of the spaces in between. So this one's good for capitalizing the first character of each word in a string. You can see in the example, we have Python programming, and then we're just calling the title method here, and we get Python programming with capital letters. I'll use it with this different example. In this case, we have text4 dot title. And I can run that. And now, remember, text4 is George Washington. All lowercase, and I get capitalized names here. Any questions on that? Great. Yeah, it looks like we topped out. It looks like we have about 34 participants right now. Do I have some of my TAs in here? I'm gonna see. There's one, there's two, so I have two TAs in here. Awesome. All right, let's move on. The strip method will remove leading and trailing white space from a string. So it'll just automatically get rid of any kind of spaces or anything on either side of like the final alphanumeric characters or any other characters. So again, sometimes when you're working with data coming in that you don't know kind of how it's formatted, there may be extra spaces, and we have to think about how we can remove those, because we don't want to just send that uncleaned data into our backend to be processed. You kind of want to do some data cleaning first. And this is like one of those things that we would do. We would kind of make sure we're getting rid of any kind of extraneous stuff on either side of an input. In this case, it'll just do exactly what this is showing. It shows the text. It says this is some text with some spaces, and just reduces those spaces. I have another example as well. Text 5 dot strip. Do that. And then I can run it. And if you notice, all these spaces in front of hey, hey, and behind hey, hey are all gone. And now I just have a nice clean string. It does not get rid of spaces in between. So it will not get rid of those, only on the outside edges. Okay, let's move to our next one here. Okay, a lot of these next ones here, well, a couple of these, then we have some more further down. So some of these next ones here are going to give you back a Boolean. So if you remember from last week, with Boolean statements, and then what else did we dive into? We dove into like the if and else statements.
The false, the truthy conditional statements.
Yeah, yeah. So, you can use, so if you think about how we can use those to kind of get into logic branching with if and, else if and else, this is, we could use these to kind of to start those processes. Let's say, for example, you have a list of, 10,000 names and you want to find, all the people that have the first name of Brad. uh, well, you could do that. You could actually run this string starts with and run a loop over your list of names, and then just run an if statement. If string starts with and you have the word Brad in there, uh, you can have it do something like have it add that name to a new list. So you can return all the Brads or give you a count. There's all sorts of stuff you can build with that. So I can just go ahead and show this one here. So text 6 dot starts with, and I think I can just put in random characters. Let's try T. So here I have text 6 start with T. I don't remember what I put up there. Text 6. I mean, I can look now. I have pizza as the first word, right? So I can just say T initially, right? And I can run this, and it's going to give me a false. So it doesn't start with a T, but I know it does start with a P. So I can put a P in here. I can run that. Hey, it gives me a true. So I know the first word of that string in text 6 starts with a P. And of course, I know what it is. So I can do pizza. I can run that. I don't know why it's scrolling on me. Uh, and pizza is the first word. Now, what if I did lowercase? Now it's false. Do we know why? So I have the word pizza right here. Ooh, okay. So Nika said ASCII. Okay. So case says strings are case sensitive. They are. Strings are case sensitive. Uh, in that subject of ASCII, I will share that as well at the end of the lesson. There's a thing called the ASCII table, and what that has, it gives you actual values to various characters, and it's all agreed upon, so it's the same value for the characters, across languages. But there's an actual ASCII value for capital P versus a lowercase p. And if you work with strings a lot, you kind of get familiar with it. You kind of maybe even memorize some of the characters. I don't know them. I always have to look up an ASCII table. But you can use that to compare your strings. And whenever actually you're forcing it to go, if you're using these methods to go uppercase to lowercase, behind the scenes, it's actually referencing the other ASCII character for those lowercase values. So it'll be referencing that. So in this case, though, with the starts with, okay, this lowercase p is not the same as the uppercase p. So I'm going to get a false. It does not start with the lowercase p. Is there something we can do to maybe still keep this here, but get a true result? Okay, so Jordan says chain methods. Okay. So maybe do something um, like here. So text 6 dot maybe lower, maybe like that. There we go. So in place, I'm saying, hey, in text 6, I kind of I want to go ahead and make it all lowercase because I really don't care if it's an uppercase or lowercase. I just want to see if it's a human readable P. There's two of them. So I can then go ahead and make it lowercase first and then check to see if it's, lowercase pizza in that case. So that does make a difference. And that's how you kind of chain methods. You could also, you know, and this is what I recommend, you could probably do something like this. Just redefine a new variable. There's no harm in redefining a new variable. So in this case, we can just say lower text equals text 6 dot lower. And then we can say lower text here. We can do something like that and kind of split it up, and we'll still get a true result. So I recommend kind of doing it this way, even though it is more code. If you're comfortable with training methods, fine. If you're a little more comfortable with that, but if you're not, I recommend doing it that way just so you can see the process happen, and you can always reference. Then your lower text will always be in memory, and you can reference that as you go figure out a problem, because your problems that you face, which you've already seen in the application, if you started the challenges for the application, the part two for Code Platoon, if you've started those, you're going to have to do several steps to come up with a solution. So doing it this way really helps you kind of see the process happening. So I recommend doing it that way. But that's exactly what you would do. So that starts with, you can make it case insensitive by doing it this way, and it'll catch stuff. Any questions on that? Oh, I believe you do. With the holiday, I really didn't talk to many people on staff. Let me ask that question as far as accessing the application. I know if you went through the normal application process and you have already opened part two, um, then you should have access. But I will ask the question again. Let me write that down actually as a to-do item.
Can I ask a related question, Aaron? Is that okay?
Yeah, go ahead.
I don't know if you can hear me better. I'm my audio was not good before, but
Yep, I can hear you.
I didn't submit the application because if you go to the application now and ask you to choose a start date and the only option is June, so I didn't submit that because I said I don't want to do June.
Yeah.
So I'm not sure what to do, how to get in the queue.
So, I mean, I don't again, I can ask a question. I don't think there's any harm in starting it because I know that like a part two of the application, could be applied to later cohorts. In this case, I know if you go through Quick Pass and you finish this and you finish live coding, they will put you into Whiskey Platoon because it starts like a week later. So, and they have a very deliberate process for that. So if you want to say that date, you can, because you're in Quick Pass already and you're enrolled, they can always move you. So, but I can still ask the question. That's a good one.
Okay, I just want to make sure that I don't need to submit an application.
Yeah.
Thank you.
Hey, Aaron, quick question.
Yeah.
How come for the lower example, we didn't have to put anything inside of the parentheses for lower, and it still gave us the result that we were looking for once we, ran that piece of code?
That's a good question. I'd actually want to explain that. So, there's a lot happening on this line. It doesn't seem like a lot happening. There is a lot happening, right? So for one, we are assigning something, right? So we have this new variable that we're designating as lower text, right? So if you remember from day one, I said, hey, when you make a variable, you can make a variable all day with anything that you want. And that's okay. I recommend like making variables, kind of see how your data is, changing and doing stuff. So in this case, we're making a new variable called lower text, and we're saying, hey, I'm going to assign it to whatever the result of this thing is going on. So what is this thing? Well, this thing is referencing a variable that's already been defined up in this cell up here. So with Jupyter Notebooks, again, it's separate cells, but it's a continuous program. So they're all connected, if you will. Since I've run this before, it's in memory. All these variables are in memory already. And then I'm saying dot, and then I have this stuff in green, right? And the green with these parentheses, remember, signify a method. So this is a method, and it's like a function, just like we, show how we define a function. There's functions defined already in Python behind the scenes that we don't have to worry about coding. We just have to run them. So we don't care what's in those methods as long as we give it a certain input that it calls for and it gives us the expected output. That's all we care about. And remember, functions are defined by like the function name or a method name and the open and closing parentheses. And remember what goes inside of those parentheses. Do you remember what that's called? That's a Python term that we were given.
The value?
Not value. There's like two words for it. The official term that I introduced was a parameter. So it's a parameter that you put into a function. Do you remember that?
Yep.
Yeah, a parameter, or you can call it, some people call them arguments, either way. So the parameters go in there. Okay. So we have that. So I'm saying, hey, I want to run this method on text6, and it does not require any parameters. So I didn't put anything in there because it's just going to run whatever's on here. And then it's going to assign it to lower text. And then on this line, I'm doing the same process that's happening over here. And I'm saying, hey, now I have lower text. I want to run another method, but this time my method does take an argument. So I have to put an argument here. I believe starts with, you have to have an argument. So
Okay. So some don't need arguments, some do.
right. And so in this case, right, so you can write a function or a method that has, that requires two arguments, right? So let's say you have, and I'll show you some examples when we get, down to where we're kind of doing exercises and kind of going over, maybe the older stuff and some of the newer stuff, where when you write it, like it requires two arguments. If you try and call it without putting those two arguments, you'll get an error from Python. And it'll say, hey, this function you're calling requires two, but you only provided one. Or conversely, you give it three arguments and it only expects two, it'll also give you an error. So you kind of have to know, and it's a skill that takes some time to develop when you start writing custom functions, like, when you're thinking about what you have to give it as arguments, it just takes a bit to develop. But yeah, so that's the reason why it looks that way. So you don't have those arguments in there, or you do, or you have requirements. So in this case, we have starts with pizza. I'm actually curious to see if I have to have something in there. I can't remember if I do or not. So if I run this, yep. So here's that error, that type error that I just talked about. Starts with takes at least one argument. So the code behind the scenes,
Okay.
yeah, it requires something. It needs me to give it something. I didn't give it anything, so it said 0 is given, so I can't go forth. I just stop and give you an error. So yeah, that was a good question. I like that because I was able to give you an explanation of what's going on. So that's good.
Hey, Aaron,
Yeah.
if you did put a letter in that parameter for lower, it would just lower that letter, correct? Like it in the string?
I don't know that either. We'll find out. Let's go ahead. What was it was like pizza, right? So let's just do capital P. I don't think it will. I think it will error out too. Let me see. Yeah. So here, lower takes no arguments, but one was given. So you can't do that either.
So if it was all capitalized, then you just put like say just lower Z, it wouldn't lower just the Z's.
No, it's going to
Okay,
lower the entire string.
got it.
All you can do. Yeah, that's the functionality of it.
Thanks.
Right. But if you want to just lowercase some portion of a string, there's ways around that. Some of the methods we're going to show, like how to find and like doing string slicing, you can get portions of strings and then edit those. You can save those to new variables and change them. So there's infinite possibilities with it. And these are the tools that allow you to go to that character level and break a string into certain parts depending on what you have. Your job as a developer is to come up with a way that works with all the stuff coming in. So you're going to have, and this will kind of goes into the computational thinking. When you have a problem and you're trying to solve it, right? So you're trying to solve the problem of, this data coming in, And you expect it mostly to have a certain form, right? So let's say, for example, it's always going to have like 3 names in it, right? Or most of the time will. But what if it has 2 names? Or what if it has no names? How do you handle that? How do you search for names when there are no names? And how do you make your code handle errors if they pop up? And so that's going to be something you have to figure out as you get more comfortable with these foundational concepts, because combining these foundational concepts into more complex ways of handling writing a program, that's exactly the goal. And so, that's why this foundational stuff is super important, because it all builds just like math. When you first learn about the basic operations, then you start learning about algebra and all those, special methods like the FOIL method, so on and so forth. Those things you have to kind of understand and then build upon and build more complex structures. So let's see here what we have next. So we had I believe we went over strip, and we're at starts with, right? So we're next is ends with. Let me add a new block here. Let me go ahead and just do like that, run that. So we'll just go away, add new code. So let's kind of keep the same theme. Let's go ahead and make a new, let's make a new variable called, we'll just redefine it. It's fine. So lower text equals text 7 dot lower. I'm going to do my open and close parentheses for that method. In this case, we want to say lower text ends with party. Okay, I want to see if the text 7 in its lowercase form, which it should already be lowercase, but that's fine. We can go ahead and make sure it's lowercase in case it wasn't. We would say if it ends with party. In this case, it does, because in text 7, the last word is party. So that's how you would use that. You can use ends with to kind of see what's at the end of a string if that's what you're looking for, right? A real world example for this, let's say you get a URL in and you only want to process, let's say you're just getting a feed of URLs in from some process that you have going on, and your job is to make sure that you filter out any URLs that end with .gov, right? You would use this to help, as a string comes in, you want to evaluate it. You want to see what it ends with. You want to say, okay, well, if this string ends with .gov, I want to do something with the string. It's a special thing. I want to make sure I grab that URL and, save it in my collection of .gov URLs. That would be a very realistic case for grabbing links. So any questions on those? Starts with and ends with.
Hey, Aaron, one quick question. When you defined lower text as text 6, and then you redefined it as, and the next one is text 7, does that completely redefine it, or does that mean it's both text 6 and text 7?
It is text 7. So if I were to make a new cell, in fact, let me just go ahead and run this one again, right? So I ran that, right? And so now if I want to make a new code cell in here, and I say just what is lower text, right? If I run that, pizza is the first word. Okay. And then I go here, but I don't run this at all. So I haven't run this yet because I ran this one afterwards. So you see the 39, the 40 here. So this is like the last cell to be run. If I were to go here and make a new code cell, and then run that, it's going to give me pizza's first word because that's what has been run. But if I redefine it by hitting play on here and I'm redefining lower text, And I run this again, it changes to last word is party because I redefined it. Strings can only be redefined. They cannot be changed in place. So when you're writing it like a normal Python file, that has just one window and you have to write it, it'll go from top to bottom, unless you have functions there that kind of throw the order off. But it'll run from top to bottom. So if you define something and then you redefine it into something else, it'll stay that way until you redefine it again. Does that make sense? Does that answer your question?
Yeah, I got it. Thanks.
Great. All right. All right, moving on. Go ahead.
Aaron, real quickly, is it? I'm guessing it's just the program that you're using. You don't have to print type, or you don't have to type print for it to print.
I don't. So I can. In this case, all it's doing is just evaluating it really quick and giving me the output. So I don't have to do that, but I could also write the print statement. I know with some like the REPL, I believe REPL, you have to write the word print.
Right. Okay.
And with this one as well, like if I put something below it, it only gives me the last one. It doesn't give me. So
Got it. Okay. Thank you.
yep. Okay. Let me go ahead and add another code block. Okay. All right, so this last one here, the dot find, this one here searches for a substring within a string. So you can already tell that I'm going to have an argument in that find method, because I have to provide a substring. I can't just have an empty or empty string, or I can't have nothing in there. So I have to have some sort of argument. And it's going to search for a substring within a string and return the index of the first occurrence or a -1 if not found. So in this case, it's going to give you an index. So remember when I was accessing a certain letter in a string, and it would give me, I have to use an index to find the first letter. In this case, it's going to find the whatever I'm looking for and give me the first occurrence of that happening. So not all occurrences, only the first occurrence. So you want to use it for locating, extracting specific information from a text. So, to add on to my URL example, when you have .gov URLs, what if I want to further filter that down and say, hey, if it's a .gov, I also just want to, I also want to grab URLs that have USDA.gov or something like that. And, you can search for a substring. So you want to go through that, in that string, just run the find to find USDA in that URL. If it already was a .gov, you could do that. You could also just use an if statement, if you will, and just look for that string if it's in there. So there's different ways to evaluate strings. In this case, it's a find method, and it will give you back a index value. In the example here, we have Python as a powerful language. Python is fun. And we run the text.find method, and we want to look for Python. Again, it's going to be case sensitive. So if you have a capital letter in there and you're looking for all lowercase, it's going to return -1. In this case here, it's going to return a 0 because the 0 index is where the first occurrence happens. That's a pretty good example. It's pretty straightforward. In this example, I have a text and it's a long string. And remember, we talked about the different types of strings. I have this double quote here, and then I have single quote. And then I have this triple quote one here. This is a multi-line string, which means I can move to another line and just continue the string. And as long as I don't have another triple quote, and it can be single or double quotes, it'll just continue to give me a string. So it just throws some new line characters in there behind the scenes. In our text, it's a little quick text I came up with about, where's Waldo, right? And we have to find Waldo in the string. Well, I don't want to go read the entire thing. What if this was, a novel and the word Waldo only appeared once, right? Python can find it in a very, very short amount of time. and we can use that to our advantage. So we have this string. It's really long. Obviously, you could read the 5 lines and find where Waldo is, which is, right here, right? But let's go ahead and programmatically find it. So in this case, we could say text 8 dot find, and we can say Waldo. Before I run this, what am I going to get?
Fault or error, because Waldo needs to be capitalized.
So he says error. Does anybody else think I'm going to get something else? Athena says -1. Run that. Sure enough, I get a -1 because of the capitalization problem. How can I make it case insensitive? Again, I can say lower. I can chain my methods. I can run that. And now I get a 218. So Waldo starts at index 218. So that's a way to find it. But what if I want to return the word Waldo? So yeah, I found the index, but I don't want to return the index. I mean, I guess I can then, maybe, access I know the W is at index 218, but what if I want to actually pull out the word Waldo? How could I do that? Nika says slice it out. So yeah, I can possibly, let's see what I can do here. So I can say, well, I know I want to say, let's make a found Waldo equals text 8 dot lower, because I want to do it case insensitive. Find Waldo. Okay. And let's rename this. That's not really good. I know, what am I going to get back from this? Well, it's right up here. It's going to be an index, right? So let's say it's Waldo index or something like that. So Waldo IDX. So Waldo index. Okay. Well, then I can say, okay, well, text 8. Again, I know where 218 is. If I did that and I printed that, I get back the capital W. So there it is. Okay. But I can also slice. And I haven't really gone over this, but I'm going to go ahead and give you a quick introduction. I can say, well, 218, and I do a colon. And then I can say, well, I need 5 letters. So I start at 218, and I can go, well, 219, 220, 221, 222, 223. So 223. If I do that and I run this, I get Waldo. Okay. This here is not very, it's not very, you're hard coding values, and that's what you really don't want to do. So instead of actually doing 218, because I want this to find Waldo wherever it is, not just in that one location. I know it's in 218 right now, but what if I want to find Waldo in any type of string? So Nika's asking, could you search as a substring? You could. Yeah, you could search as a substring. But because I am searching as a substring, I'm finding right here. So let's do something different though. I've already defined the Waldo index as 218. So instead of using 218, let's use Waldo index, because we know Waldo index equals 218 in this case. So Waldo index. And then here, well, I don't need to use an actual number there either, because I can say Waldo index to, well, I can just add 5 to it. Waldo. So I can say Waldo index plus 5. There we go. So now I don't have to actually, now I can find Waldo wherever it is, and I can put Waldo in a different location. So I can say, well, I don't want Waldo to be there. And I'll just put it here, for example. So Waldo, and I'll run this again. And now I'm going to go ahead and print Waldo index so we can see where it is before we run it. Now it's at 95, but I get the same result. I get Waldo. Yeah, and so that's the power of, trying to abstract out those hard-coded values and put those into slices. So in this case, that's exactly what I'm doing. I'm defining. So the brackets, Daniel, again, I really didn't cover that. I'm going to cover that later, but it's just the brackets are slicing with a colon. Not with find. So in this case, we know that, like, I wouldn't have with like a Where's Waldo, puzzle. There's only one Waldo in the puzzle. So it would make sense to use find if I was trying to find Waldo text, because there would only be one occurrence of Waldo. But if you have multiple instances of something, you probably want to use a loop. So there's ways you can, like, turn the string into list and then, go over the string or search for a substring. So there's other ways around it. But in this case, we're just trying to find the first occurrence, and we did. And we can find it in now separate locations, not just one. So in this case, I can get rid of it here. Run that again. So it's now text date saved without that extra Waldo in there. I can run it again here, and it'll go back to 218 and give me Waldo. And so now so this is 218. And this one is 223. It's just, I don't have to see that. It's just defined in the code. Like right now, if I ran it again, it'll keep giving me back the same result. Because it didn't remove it. It just read it. And then I saved this as a separate, variable. No, it does not remove. It just finds. So it just locates. It does not remove. Let me see how many more I have. I have count, replace, split, join. I have quite a few. Let's go ahead and take a break, because we've been actually at it for about an hour now. Let's go ahead and take a 10-minute break and come back at 7:10. I'll go ahead and pause the recording. Zoom recording. Okay, we're back from break, and we're going to resume. So before we've gone over 8 of the methods that we have, and we stopped with find, where we could find the index in our example of Waldo, and then we could use that index to maybe print out a word, or there's other things you can do with that index once you have it. But it's just another one of those ways to find either a substring inside of a string. Conversely, we have a string.count, which counts the number of non-overlapping occurrences of a substring in a string. In the example, we have our text is we have multiple occurrences of the word Python, and we want to count how many times Python occurs. We can do text.count and then put it in the string. So we have to give this method an argument of whatever substring we want. We put in Python, and we get back a count. So we get back a number. integer of how many times that has occurred. This is text, or not text, it's case sensitive. So again, you can use that kind of method I did where I just made my entire, incoming string made all lowercase, then just search for the lowercase version. But if you're actually searching for a case sensitive term, then you don't want to do that, of course. So in this case, we have, we want to count Python. Let me move. So I did get the question about moving this large, like multiple variable thing. I just kind of wanted to put it out of the way so I can do my operations, but I'll go ahead and copy it and move it to a new cell and kind of run it again. So let's try and go right after this. Here, we'll add a couple code cells and we'll throw this one right here. I don't even think I'm doing it. We can actually run this count one on the same one. So in this case, we have text 8, and I see a question. So Michael, I don't know. Again, I'm not familiar about a lot of these financial pieces, the grants and everything else. Really, Tish is our expert, and you can email her directly, tish@coplatoon.org, and ask that question. And she's pretty responsive, so she'll get back to you pretty quickly. So I would ask that question to Tish. Let me run this cell so I have them all in memory again. Okay, and so now we're back into using another method here. We have our string.count. So in this case, we're going to do text 8. And I'm going to be pretty boring with this. Let's say count. Let's just find the string the, since I do have a few of them in there. Okay, so I have 6 occurrences of the word the in this form. So we can read it and find one of them. There's one there. Oh, there's another one. Okay. But what if I changed it to a capital T? I found 2 capital THE, and one's going to be here. So it's not the actual word. And then one is here. So you can see there's a bit of limitations with this, that it's really going to find you a substring. And sometimes it'll, if your word is actually part of a bigger word, and you're actually trying to find that, that could cause you some problems. So that kind of introduces one of the problems with using these methods. They're going to do exactly what they're designed to do. And sometimes you'll make the mental leap that Python doesn't make, where you're going to assume it's going to, ignore something if it's part of a bigger word. But in this case, it's not going to. It's going to go ahead and give that to you, because that is a substring THE, but that's not what you wanted. You don't want there. You want the. You only want capital T. And if I were to do the lower, and then change that back to lowercase, I should get an 8. Yep. So I get an 8. Now it's counted all of them and this one. So I don't want that. If I'm looking for only the word the, I want to ignore those. You'll have to write more logic to kind of ignore those. And those are what we call edge cases, where it's something that your program is doing exactly what was designed, but you didn't anticipate like some weird case happening where, oh wait, this word is actually a portion of a bigger word, and I don't want that. So you'll have to figure out how to ignore that. So that's just a good thought exercise. I can share this text with you if you want to play with some of these methods on your own. I can throw them into the Slack so you can copy that and do like a Where's Waldo thing, or any other examples we have from class. That way you can kind of get a better understanding. If you want, I can throw those in there. Will do. Too easy. Okay, here. In this next example, we have string.replace, where this will replace all occurrences of a specified substring with another string. And so you can use it to transform text if you need to substitute. In this nice example here, we have our text is I like apples, but I don't like oranges. And you want to replace it. You want to replace apples with bananas. So then it comes back, I like bananas, but I don't like oranges. The replace method does require both, what you want to replace and then what you want to replace it with. So it will require 2 arguments, just like we saw before, where if we didn't put something in the correct way, Python will give us an error, and it will tell you, hey, I was expecting 2 arguments, but you only gave me 1, or you gave me none. So just make sure you look out for those errors. Don't get like thrown off by them. Just read what the error is telling you. Usually it's pretty descriptive. So you can always Google an error too. If you have an error and you're like, I don't really know what this means, take that error, copy and paste it into Google, and then see what comes up, because usually going to get sent to like a Stack Overflow page, and it will help give you a description of like what the error means. Someone will put a comment in there about what it means. So don't be afraid to Google things. If it's confusing to you, don't just sit there and stare at it. Try and do things like Googling, or asking something in the channel. Again, I just want to make sure everyone's aware, like, I don't expect you to be any like coding level at all. So it's not embarrassing to, if it's something I covered on day 1, you're not expected to know it, like, or even know where to find it. Like maybe you missed that portion or whatever. Ask the question, because I guarantee someone else in this class has the same question. It always happens. And, and if you see that someone asked that question and you were wondering the same thing, put a comment there. Hey, I was wondering the same thing, actually. I was actually stuck on the same spot. So that's always good to do. Here, I can then move on. I can say, my text. Actually, let's do it this way. Let's keep it this way. And we're going to replace it. So dot replace. Oop, I have 2 dots, don't I? Replace the with, let's do milkshake. Put some quotes around that. One thing I actually want to see is if it actually saves it. And we can run this real quick. So we have text date here. I'm going to rerun this to make sure we have text date as the original text I intended. Okay. So if you look here, it didn't actually change anything. So I didn't replace the with milkshake. Because it doesn't actually change it. It does do it if you assign it as a new variable. So if I did like that, and then I can print text 8 and print let's try it that way. Okay. Okay, in this case, it's all lowercase. I did not do lower. So I replaced all of these with milkshake. So if there's like a, of course, this is the end of the first one. And then there was a second one. So now all of these are replaced with milkshake. And you can see that. So we'll not change it permanently. Now you could print it like this, run the print function on this replace function. But it will not, like, if you just run that and not assign it to a new variable, it's not going to give it to you as, it's not going to change this this variable at all. It'll just run it and then won't return it and reassign text8 as that change stuff. It's just going to give it to you. If you want to assign it to a variable, then you can. So just, that's something you'll need to get used to. It's probably not going to be intuitive at first, because sometimes, especially with lists, when you're doing these list methods, they're going to change the list in place and you'll have changed data. But because strings are immutable, it's not going to change it in place. So it'll do the method on there, but you'll need to assign it as a new variable. Now I could permanently change it by just redefining it as text8. So here I could say text8 there. And I don't know why it's scrolling on me. That was weird. And now if I run it, it's going to change it because I redefined it in place. So if you take a look at how I did that, let me rerun it here. So now I've replaced it back with the original string. What's happening here on this line when I run this, I'm saying, hey, I have a new variable called text8. And I want to assign it as what text8 already is now. I want to replace the word the with milkshake, and then I want to assign it to it. So I'm basically taking what the old form was and then changing it and then reassigning it there. So it's weird because it's kind of out of order from the way you read, but that's exactly what's happening. So that, instead of making a new variable, I could do that, but now I've changed my original variable. In this case, I don't want to do that. So I'm going to go back to here and then print change text here. Does everybody understand how that works? There we go. Any questions on replace? All right, let's move on to split. So these next two are, they complement each other. So the string split will, split a string into a list of whatever, whatever the string was upon the, delimiter that you made or you assigned. The join method will take a list of strings and put them together, and of course use whatever you want to, put in between them. So if you want to put a comma in between those strings, you can do that with the join. So really they're going to be opposites of each other. And I'll go ahead and start with using text8 because that's a nice long string and we can see what's happening. So let's go ahead and say let's call it text. I'm going to call it my text list. And that's equal to text8 dot split. And I think it's going to default onto white space. So here, again, with an IDE, when you mouse over a method, it's going to give you a quick description. And it says returns a list of substrings in the string using sep as the separator string. So in this case here, if it's set to none, so if I don't actually put anything there, it'll split any white space character, including all those new line, carriage returns, tabs, F, remember what F is, and spaces. So it'll discard empty strings from the result. So if I were just to run this as is with no arguments, and then print it, so I'm going to go ahead and I'm not going to print it, but I'll just do this right here. If I were to run that, there's my list. It would just go all the way down and it truncates it because I have a whole bunch of words in there. Now, if I were to print it, and run that, it'll do it horizontally, but it's going to be the same list. But this time it will give me the entire list. Any questions on that? So that's how I got every word. How can I separate it? How can I separate this into a list of sentences? All right, so Athena says split and put a period there. So just like this. If I run this, I believe we'll get an error. It'll say invalid syntax.
It's missing the quotations around it.
Yep, because it's gonna be a substring, so I have to make sure it's a string. So, yep. So with the quotes, so there's my substring. If I run that now, I have a list with strings. So I have, there was a man we found to be most elusive in the world. That's the first item in the list. So I guess I can even go further and I can say, okay, well, text list at the index of 0. There we go. That's the first sentence. So I can take a string and then split it. Now I need a delimiter I want. So I could do no delimiter and I just get every word, or I can say, well, I want every period. So I do that. So that's how I can find how many sentences are in here, right? So I could say, okay, well, I want to just split it on every period. That should give me all the sentences. Or will it? Are there any times where maybe if I have a period, it may not be a sentence? Yeah, it could be like a .com or Mr., right? So MR dot or Mrs. You know, or like if we're talking about geography, like Mount St. Helens, MT dot, like it'll split it and then say that's a sentence, and it may not be. So there's some edge cases there. If I'm trying to find how many sentences are in a string, you know, I would need to kind of work that into my code. But this is a good first hack, at least. You know, hey, there's, you know, how many sentences are in here? How can I find out how many sentences are in here? Yeah, or other punctuation, right? Because, you know, sentences don't end just with periods. They end with question marks, exclamation points, and all the other punctuation. So now we're adding a little bit more complexity if we really want to find how many sentences there are. But in this case, we have a nice simple paragraph that has just some sentences. How can I programmatically find out how many sentences I have here? What could I use to get how many sentences I have without actually counting them? This is going a little bit away from it, but I really want to kind of hit this home because we will be talking about this later. In this case, I want to use the word len and then do text lists. So there's nine sentences in this paragraph because it's split 9 times on the periods, or 8 times, if you will. You know, there's 8 periods, I think, in between. But yeah, so there's 9 sentences in there. I just use this len or length of the text list to give me the length of this resultant list here. So that's a way to find how many sentences are in this paragraph. So if I want to join it back together as one string, I would use this string.join. So in this case, what I'm going to do is I'm going to say, hey, I want to join a list of strings in a single string using the current string as a separator. So here I have already an example of, you know, fruits in a list. I want to join them. The syntax is a little wonky, and it takes a bit used to, but you're going to want to put what you want to join the list on first. So you want to, in this case, in this text here, it's saying, you know, comma, I want to join them on a comma space. So there's a comma space in this substring, and then you want to run that method on that. So it's dot join, and then your list is going to be your argument in the join method. So it's a little backwards looking, but it's still pretty intuitive. So here in this case, I want to say, okay, well, dot space, dot join text list like that. And I can say stored text equals, and then I'm going to call it restored text. And there it is. It's back. If I print it, it has those like escape characters. I'm about to talk about those escape characters, like this little \n is a new line character, and that / is the escape character for that. So there. It put it back. It added some extra space in there. So maybe I can do it like this, like that. There we go. So I split it, and then I put it back together with the dot join. Any questions on that? Okay. So the next few methods that we have, I think it's 5. Yeah, 5 of them. They're all going to end up with a Boolean. So when you run these, they're going to be very similar. And this one kind of has wonky formatting. We'll fix that. But in this case here, they're related because one's going to look only for like alphabetic, so they're letters. Next one's going to be numeric. So it's all stuff in a string. One's going to be both, so alphanumeric and letters or digits, and then lowercase and uppercase. So they're going to be really related. So I'm going to just show some examples here in the code so you can kind of see what's going on. Let me go ahead and add a few more. Okay. So we take a look here and just check to see if, first we take a look at is alpha. We're going to check if all the characters in that string are alphabetic. So the use case for a lot of these is going to be for validation. And this is I guess is a really good kind of segue into, when you're thinking about, programming and you're relying on users of your program to give you an input. One piece of advice to just know right off the bat is never trust what your users are entering, because they're going to enter something that you're not expecting. And so these tools here, this is alpha, is numeric, these are tools to help you kind of filter out bad data entry from users, because people put in typos all the time. If you don't want any numbers in your data field that you're expecting, you'll want to run some of these methods on that input stream coming in, so you can kind of filter out right away, so it doesn't even get to your backend, get to the database, and your database has wonky data. So well, that may not make much sense now, but just know that these are really good for validating input. So you are expecting the right kind of data coming in, so you can use to filter out stuff. So it's all pretty easy. They all return Booleans, so you can use these as conditions in if and else statements to run your program. So I'll just copy this one over because these are pretty simple examples, and they're pretty clear. Run this one here. We have our fruits. Not that one. Not that. Sorry, let's just go apple. Okay, we'll just do fruit as apple. And so is alpha is going to be a Boolean. Fruit is ALPHA. And call it, oops, is alpha. Run that, and I get true. Now, if I have a 2 in there and I run it, I'm going to get a false. So the is alpha will filter it out. In this case, I have, I'm going to skip is numeric and go to is al num. So here, now if I run this with al num, I know it's kind of split up, so it's weird to see, but I can do it that way. And I'll go ahead and redefine it as is al num. And now Apple 2 is true. Run that. That's also true. Run that. That's also true. And you can imagine what is numeric is going to do. Is numeric is going to see numbers. It's going to convert those into numbers, make sure it's going to check to see if it is a number, and then return you a result, true or false, if it is. So you have only alpha, only numeric, and then is al num is alphanumeric, so both letters and numbers. Conversely, you can check to see if a string is all lowercase or is all uppercase, and it will give you a true or false result on those. So these are all pretty simple. They're going to return a Boolean in each example. So here I can actually go back to my text. So let's do restored text. Dot is al num. What am I going to get a result on this? What is it going to be? Let's call it para checker or paragraph checker. Okay, I got one false. I'm running is al num. Athena says false. Anybody else have an answer that's different? Out because of the new line. Run that, it's false because of that, and there's also punctuation in there too. Let's try is upper. Of course, that's going to be false as well. If I cast it or make them all uppercase and then check to see if it's really uppercase, it's going to come back to true, of course. Any questions on those? Again, they return a Boolean, and you can use those in those if and else statements. Okay. Next, the next one we have is interpolated strings. So this is what we called F strings. So F strings, you can embed expressions inside of them using those curly braces. And you saw this last week in a couple of my examples. In this case, we have a name of Alice, and we want to say our greeting is equal to hello, and then we just put these curly braces and put that variable name in there. That way we can just change the value of a variable name, and we will always get whatever the name is. We don't have to actually hard code it. So they're pretty powerful. It's nice because it's pretty readable too. One of the old ways Python did like that string interpolation is this way, and you may see this. You know, if you go forth, finish Platoon, and get a job as a developer, you may find some old code base that actually has this. I just ran to one. I was processing a machine learning algorithm from, it's from academia. So a lot of those, ML students don't really know how to like code for web development or software engineering. They know how to code for machine learning. And so there, a lot of their practices are not very, they're not very good. Like they'll have lots of repeating code, or they'll use old stuff. And they had a lot of this where they'll have like the string, they're trying to do like some of the machine learning outputs for the logs, and they would have like this and then this, and they would have a dot format, and then they would have like their variable name or whatever the case was, and then they would, in this case, I'm running a method. Let me see if I can make it. Oh, I see what I was doing. I was running over the entire thing. But yeah, so the dot format will then allow you to kind of inject these things into these like standalone curly braces. Just looks weird. A little harder to read than an F string, which I can just throw in, a variable name right in the string. It's just a little bit easier to read. So it just makes it a bit easier. You can also throw in, so if you remember we found Waldo, right? So we found that up here. We can actually define this as the Waldo name. Let me see where I'm going with this here. Or I can actually, I'll keep it this way, actually. I'll keep it this way. That'll be fine. Waldo index. So I can say print F I found Waldo at index Waldo index. And so there, I injected the Waldo index right there. And if I were to go back up in that paragraph and change where Waldo is, and I could run this again, and it will change that Waldo index because I made it a variable that I can just inject into the text. So it's just something that makes it a lot more responsive to changes of input. And I can even go further than I will after the exercises, but we'll keep that in mind. So that was interpolated strings. You've been looking at these escape sequences in a bit, especially in this long paragraph I had with these new line characters. Let me see. See what's happening here. I don't think that's right. But in this case, we have a new line character, so it's a \n, and then the \t is a tab, so it'll just give you a tab space. And then let me see what else we have here. I don't know why that one didn't show up. I thought I fixed that. Go back to that. Give me 1 second. Oh, it's showing up there. I wonder if I have to do another / there. But I do. Okay. If you want to do a \, as in your text, you'll have to do like a double / to see it in the string. Up here. And then the escape sequence, like if you want to use a double quote inside of another double quote, you have to use an escape. So the \, and then the same with the single quote. So in this example, we have multi-line, and I'll get to your question in a second. I want to, get in this multi-line here. you can make this a multi-line string on a single line of code by putting your new line character in there. So you put in just right in the middle of the string this \n, and it will print out on a new line. So I can do that here. And I can actually show the other one too. And if I ran this, this is a multi-line, and then the output, it gives you a new line. And this IDE actually shows you what it is. In this case, it made a new line and put the last word on there. If I ran this, it's no longer a multi-line string, but it'll have a tab. So now it's a multi-line /T for tab string. If I want to put a quote in there like that, I can actually put it in there and it won't mess up the string. If I didn't have that escape character in there, the string stops here, and then Python's like, I don't know what this is after that. So if you put an escape character in there, it'll allow you to put that quote in there even with double quotes. Yep. Okay. Yep. Thanks, Tyler, for answering that. If you want to do a backslash, so you need a backslash character in your string. You need to do a double backslash to escape it, and then put it in there as part of the string, and then continue on. So it'll just give you that one that you had escaped originally. To be honest, like my everyday coding, I really don't use them very much. I know what they are. I just haven't used them very much, the escape sequences, but there are times where, you do have to use it. So it's just good to be aware of it. So in this case, we're using the escape sequences, mostly for new lines and tabs and return carriage. So just keep those. When you see those in there, you kind of know what they mean. So let's move on to slicing and reversing. This is our last bit of new material for strings. And so we can use slicing to extract part of a string. You already saw me kind of do that with the Waldo exercise, where I initially used hard-coded values. So I found Waldo index, it was at 218. I said, okay, well, I want to slice my text at 218, and I want to go at 5, so I just want to say 223. I could do that, or I can abstract it out, define my index, use that definition of the index, and then also do a quick arithmetic in here as an operation to get the same thing. And now it's responsive to whatever Waldo index ends up being based off of the find method. So that's a way to kind of make your code responsive, but that's what that slicing is. And so I showed some examples of string slicing. Again, I can go ahead and make a new one here. So my new string equals, this is the new string, and it's a great one. Okay, so now I have a new string. It's called my new string. What if I just want to get out, it's a great one? I could then say, okay, well, if this is a really long string, you don't want to sit there and have to count, right? Or if I want to pull out just the word one, right? Well, that indexing, you remember, it also goes from -1 backwards. So I know the index of the last character in my string is -1, and it counts up from there in the negatives. So if I want to find the word one, I could say last word equals my new string at the index of, well, let's find the exclamation point. So that's -1. And then I want to go ahead and last word. run that. I get the exclamation point because it's at the index of -1 of my new string. So that's how you find the individual index. Of course, you can count back. So if I want to find the O right here, I can say -1, -2, -3, -4. And then there's the index. I could find it that way. If I want to get the actual word without the exclamation point, I would need to slice it. Since I know that, I want to find the last word in there, there's several ways I can do it. I could split the string into individual words and then find the last item in that list to get my word. If I don't want to split the string up, I still want to find the last word. I can kind of do a bit of like hunting for it. I know it's going to be near the end, so I can say, well, I want to see what the string looks like. Let's go ahead and slice it. And this time I want to use negative, let's say -10. And then I want to slice it to the end. So I'm going to just not put anything that will get me to the end. And I can run it. Now I have grade 1. I'm like, oh, it's too far. Okay. Well, now I can then say maybe -6, even though I know it's going to still get some of that word. Now it's T space 1. I'm like, sweet. So -4. -4. And now I got it. I'm going from the -4 index, which is -1, 2, 3, 4, all the way to the end. If I don't want to include the exclamation point, remember the slicing, just like we did with, I'm trying to remember, where it doesn't include the last item. It's up to, but not including that last item. So if I put my -1 in here, then I'm going to go up to, but not include that -1 index, which is the end of the string. Conversely, if I want to find the word this, range, yes, thank you. I was just drawing a blank on what I talked about. If I want to start at the beginning, I can put a 0. But if I want to find the last, if I want to find the lowercase s here in the word this, remember we start at 0, so 0, 1, 2, 3, right? If I put a 3 here, I'm not going to get that. I'm not going to get that last letter because up to, but not including. So I need to go ahead and add one more. And it's up to the 4th index, which is the space, but it does not include that. So it's this. So that's the slicing. So this is kind of one of those important things where it's just the syntax of Python. We talked about some definitions and we put that link in the chat with that, the Python terms and everything else. We got to remember now we're using these curly braces in several contexts, okay? For F strings, we're using the curly braces to inject variables into a string, but we also use curly braces to define sets and dictionaries. There's just some differences in how we use them. Okay, the curly braces with colons are dictionaries. When the curly braces without that are going to be sets. So if there's no colon, there's going to be a set. Square brackets. Square brackets are going to define lists. The open and closed parentheses are going to have tuples with the commas. Oh, good question. Daniel asked, if you used 0 and then -1, would you get the entire sentence? You would not. You would get the entire sentence minus the last character. So if I did that, if I said 0 to -1, and I ran this, I'm going to get everything except that last character, which is there. So the first index, you could leave there, but you don't have to. If I did that, it'll be the same thing. But if I remove this one here and put the 0 back in, I will get the entire thing. But then why don't you just put my new string? So if I want to do, just the, is the new string. So I want to get rid of the word this. I want to count up 0, 1, 2, 3, 4. So 4 over, and then it gets rid of the word this. So 0, you would do 0. Actually, we don't need a 0. And just do a -3 here. Run that. It has the O still. So you do -4. There you go. If I don't want the space, then -5. So that indexing, I would practice that. So when we have the exercises, you can take some, do some indexing. I would really, really practice that to get used to how you can slice a string and find those characters. So there, I got rid of the great 1. Or I got rid of 1, so it's just great. So it ends with great. With slicing, you also have a third option. So this is that's not everything. So here we have our text Python, our substring. We can also define a slice as a new variable. So that's important to know. You can slice strings into substrings and use those sliced out portions for other things. In this case, we have the index of 2 up to, but not including the 5th index. So instead of just trusting this output, let's go ahead and calculate ourselves. So in this case, we have the index of 2, so 0, 1, 2. So we start at the T, and that includes the T. And we're going up to 5. So 2, 3, 4, 5. So up to, but not including the 5 is going to be a THO. To reverse a string, we can use the negative step. So we can also step. So I can slice a string here. Let's go ahead and do that. So let's just start at let's start at the 0, 1, 2, 3, 4, 5th character and go up to the end. So let's just do all the way to the end and step it every 2. If I ran that, I would just get every other. So starting here, I would get the I, and then I would get the space, and then the H, then the space, then the E, then the space, then the T, and it would jump. So the step is getting every other letter. So that's the third option when you're slicing. And you really can't get any help here, but you can always look up Python string slicing and get all the options on the Python docs. Any questions on that? And I can then, of course, reverse my string by doing a -1 and running that. And that reverses the string by using -1 step. So I'm going from the end to the beginning, and I'm going backwards. So it's going to get every single character and just put it in a backwards order. This is a pretty strong thing to remember. So I just remember how to do this. It's just a good way to flop characters around. Any questions on that? Okay. Well, in conclusion, this is what we talked about. We talked about these different methods. We started with, kind of capitalizing and getting lowercase, right? So uppercase, lowercase, moving to capitalizing, and then title case. Just different ways to manipulate strings, split them, search for different characters, find indexes. We found ways to clean data, to strip them, to get rid of all the white space on the other side. All these tools are available to you in your toolbox when you're messing with string data and you're trying to do a bit of cleaning. That's really what you're trying to do. You're manipulating and you're cleaning. And then as we add this other stuff, we look at these other data types. We're going to look at how we can, change data types. If we split, now we have our strings in a list, and so on and so forth. And we went over some Boolean ways to get some results or to evaluate our data. If we're gonna do some data validation, make sure all of our string is numeric, or if it's alphanumeric, or if it's just alpha characters. So a lot of these they are useful, and they will they will come into play in a lot of your future endeavors, especially if you continue on and get into Whiskey Platoon and you become a software engineer. You're going to use these, and you will always look them up. So you will not remember how to use them, but that's okay because they're always right there, just a Google away. So that's it with the actual lesson. So I was going to go over the assignments, but I'm going to go ahead and stop the recording first. So actually, no, I'll go ahead and go over the assignments and the recording. I think that's good for the folks who couldn't attend. So I think I've pulled them up already over here. Yeah, I did. Okay.
Where can we access the recordings from this?
There, so I'll post this one tomorrow because it takes a while for it to like process, but I'll upload them to the Code Platoon YouTube channel, and we have a quick pass channel that you can go into, a playlist, if you will, and it will have all the videos I've posted thus far. So this first exercise has it's called exclamations, and the instruction is remove the exclamation marks from the end of the words. So the words are separated by a single space, and there are no exclamation marks within a word. So in this case, we have full words in there, and we have some Boolean statements. If you look at it, it's a print. It's printing something. It's the print method, and then it has this remove exclamations method, which is defined here. So you're writing whatever the content is inside of remove exclamations. And then it's giving you the argument. So that's the string. So that's what string becomes. And then it's going to say, hey, does the result of the function equal this? Because that's that's what you want it to equal. So it's going to give you a true or false. And it's going to do that with all these examples. If you see, it's giving you a bunch of weird cases where there's one in front and behind, or there's 3 in front and nothing behind it, then a space. Now, other words, so you're going to have to evaluate all those. So it's good to kind of think about how, thanks, Tyler, for posting that. So there's the YouTube playlist link right there. So yeah, you'll have to think about how to get all of these to evaluate to true, because you want the result of the function, whatever returns back. So you need to put a return statement in there. The return statement, does it equal this test case? That's exactly what that's doing. So you should end up getting all trues. All right, the next one is reverse the order of the words and reverse the order of the letters within the words. But as a bonus, every test input will end with a punctuation mark. Either the initial string will end up with a period, a question mark, or an exclamation point. So right here, you want to keep that at the end. So how would you be able to do that? How can you reverse it and put that exclamation point at the end? So there's a couple steps you're going to have to put in there. And lastly, we have the GC content. So this one here talks about DNA, and it has the 4 components of it, which are adenine, cytosine, guanine, and thymine. And you want to get the percentage of whatever DNA string you have. So you want to write a function that will take in that DNA string, and then we'll check to see however many cytosines, guanines you have, and then give you the percentage result out. So you're going to have to do a couple things with the string to manipulate it, evaluate it, and then do some calculations to give you a result. So you're taking in a string, and you're actually going to return a float. If you look at this, our result we're trying to compare to is a float. Guarantee you're going to, when you start this and you start writing some stuff, you're going to get an error in there that's going to throw you for a loop. Please post the questions in there, because this is a really good exercise for those like weird cases that happen and how you handle them. So I'll let you guys, get into this one. And if you run into it, you can always post a question in the Slack channel. But those are the 3 exercises. We're going to be sticking around for another hour where we can go over these exercises or go over previous work. I'm going to stop the recording now. So let me stop my sharing. I'll stop the recording.